Hello, family. Welcome to another session of MathsFanatics247. This question is suitable for metric learners only on analytical geometry of circles. Okay, perfect. So now let's read the instructions. X squared plus y squared plus 8x minus 6y equals to -5 is the equation of the circle with the center M. EU is a tangent, so EU is a tangent to the circle at Q. Ne? Okay, it's a tangent here. This is a point of tangency, okay? Awesome. QMD, DAAU, and A and UQE are straight lines. DU is parallel to the x-axis. Okay, so before I even start, I'm just going to analyze this diagram based on the given information. Firstly, I was told that this is a tangent, and here I'm seeing that M is the center. So tangent theorem says this line and that line must be perpendicular. So here I'm going to have how much? I'm going to have 90 there. I'm also going to have 90 that side because of angles in a straight line. Does make sense? Perfect. So now, and then also they said this line is parallel to the x-axis. I don't know the x value, but I know that the y value must be 6 because horizontal lines, the y value doesn't change. So the equation of this line, basically it's y equals to 6 because it's 6 throughout. Awesome. Now I can go to my question. They want me to determine the coordinates of M, the center of the circle. Okay, so I'm given the equation of the circle as x squared plus y squared plus 8x minus 8x, okay, minus 6y equals to -5. So I'm going to write it in the standard form because in the standard form, I can easily extract the center. Okay, so I need to group the x's together. So x squared plus 8x plus y squared minus 6y equals to -5. Okay, so now we're going to complete the square, ladies and gentlemen. We always complete the square to write the circle in standard form. So x squared plus 8x. Okay, now I'll use a different color to emphasize this part. Ne? So when you complete the square here, you're always going to take your b, which is +8, right? And then what you do, you always start with a plus. Ne? Then you take your b, you divide it by 2, and then you square the answer, right? And then you do the same, you have to minus whatever you added so that you don't change the meaning of the equation. So it's 8/2 squared, right? Awesome. And then you have plus, okay, let's use another color. So I'm gonna go back to my red. Awesome. So y squared minus 6y. Now we need to complete the square for the y as well. Ne? Remember I said you always start with a plus. Then you take your -6, which is your b, you divide it by 2, you square. Then you minus the same thing, squared. This will be equals to -5, right? And then from here, we're going to simplify this part. So I have x squared plus 8x. This is 4 squared is 16, so it's going to be plus 16 minus 16 plus y squared minus 6y. This gives me 3, so it's 9. So it's going to be plus 9 minus 9 equals to -5. Right. And then what you do now is this. You take the first 3 terms here, which is a trinomial, a perfect square trinomial per se, ne? And you also take the first 3 terms on the y, which is also a perfect square trinomial. And then we're going to have this now. So here, I'll always have this x, you square root it. Square root of x is x. you take the sign here. So it's a what? It's a plus. And then you square root the last number, which is square root of 16 is 4. So here you're going to have 4. Then you put square there because it's going to be two of the same brackets. So we're just going to put a square there. And then I'm going to do this part now, this part. So the same thing, we square root y squared will give us y. We take the sign here, minus, we square root the last term, which will give us 3. And then we going to have that, right? Remember this part, that part, I haven't used them. So I'm going to move them to the other side of the equation. So that side I had minus 5. The negative 16 becomes positive. The negative 9 becomes positive. Then I have x plus 4 squared plus y minus 3 squared equals to, let's quickly just use a calculator. I'm a bit lazy. So it's gonna be minus 5 plus 9 plus 16, which is equals to 20. Awesome. Perfect. So now when you are here, you are going to easily get the center now. Ne? So the center is given by basically having this. So M, which is the center. Ne? This is a plus. Let me write it nicely. This number, say, okay, let me highlight them ne? With a different color. So this number and that one always gives you the center. And you always use the opposite signs. Now you see here I have plus 4. It means my x value on the center is negative 4. And then here I have negative 3. It means my y value is positive 3. Perfect. And then that should be your center. Awesome. Okay, because I need space, I'm just going to write this information here because we might need it in future. So it's what it's going to be. Okay, M is there. I can put it there, which is negative 4, coordinate 3. And then the circle equation in standard form. Okay, I'm going to write it there at the top. So it's x plus 4 squared plus y minus 3 squared equals to 20. Okay, awesome. So now we can erase it, right? Can erase this part quickly. So let me use the mouse actually. The mouse should be faster. Okay, let's see, let's erase. Awesome. So now we can move on to the next question, right? This one is done. Now they say calculate the coordinates of Q if y on Q is less than 2. Okay, the y value is less than 2. Okay, but when you look here, you can see that Q is your y-axis. It's on the y-axis. So is the y-intercept. Remember, for y-intercept, we make x 0, right? So I'm going to substitute 0 there. So 0 plus 4 squared, right? Plus, let's see, y minus 3 squared equals to 20. 4 squared will give us 16. So I'll just move it that side. Okay, let me show all steps actually. This will give us 16. Then this one here will give us still the same. Don't foil it, please. Equals to 20, right? Then you have y minus 3 squared equals to 20 minus 16, which will give us y minus 3 squared equals to what? 4, right? 4, sorry. And then we're going to square root both sides. So I have y minus 3 equals to 4. There's a square there. So I'm square rooting both sides. Remember, when you square root, this part must have a plus minus. Okay. So here I'm having y minus 3 is the same as plus minus 2, because square root of 4 is 2. Ne? Then this is what we're going to do. You're going to say y minus 3 equals to negative 2, or y minus 3 equals to positive 2. What you do, you split the plus minus into two new equations, keeping the left-hand side the same. Perfect. Let's see. This one here gives me negative 2 plus 3, which is 1. Right? Then this one here gives me y equals to 5. So which one will be the correct y value? The correct y value will be this one. Why? Because of the restriction. They told us that it's below 2. So I can conclude that my q is what? It's 0, coordinate 1. And yeah, that's it for 4.2. We can quickly jump to 4.3. We can quickly jump to 4.3. Okay. Perfect. So now let's go to 4.3. So 4.3, they want us to calculate the equation of the tangent. Okay. Now I'll show you the ideas around this question. So I have a circle, right? Then my tangent is passing through this point here. But there's a diameter that is meeting with the tangent there. You see? Then we're obviously going to have a perpendicular here because of tan radius theorem. Ne? And then what do we know about the gradients of perpendicular lines is that when we multiply them, we must get -1. In simple terms, you can always think of gradients of perpendicular lines as negative reciprocals. What I mean is this. Ne? Let's say, let me just show you a scenario here. Let's say I have line 1, which is the first line, and then I have line 2 this side. Ne? And these two lines are perpendicular. I'll just give you random gradients here, and then we're going to discuss. Ne? Let's say this is the gradient of this one is 3. The gradient of this one will be, okay, let me do this, 1 over 4, 2 over 5, 1 over 8, then 1. Okay, so the negative reciprocal, okay, let's make this negative and that negative. So if this is positive this side, remember 3, you just put over 1, right? Just like here, you put them, you always need fractions. Ne? The sign will switch. So this becomes -1 over 3. So the gradient of the second line will be this if the two lines are perpendicular. This one will be -4 over 1. This one will be +5 over 2. So you switch the sign, you also switch the numerator and the denominator. This one will be +8 over 1. This one will be -1 over 1. That makes sense? Awesome. I'm sure now you have an idea of what's gonna happen. Okay. So now we can come back here and now use the same idea we were discussing. So I need to find the equation of this line, but I have an issue because I only have 1 point there, right? I only have 1 point, which is this one, right? But my issue can be solved with what? With this line. Because on this line, I have 3 points. I have this point, that one, and that one. So if I get the gradient of this line, I already have the gradient of that one because, as we discussed earlier on, they are negative reciprocals, right? So what I'm going to do, I'm going to find small m of dq, ne? Gradient of dq, which is y2 minus y1 over x2 minus x1. Ne? So I'm going to call my q1 and then my d 2. Ne? So my y2 is 6 minus y1, which is 1 over x2 is -10 minus 0. At the top, I have 5. At the bottom, I have -10. This gives me -half. Ne? Therefore, m of what? of EU, right? Or UE must be a negative reciprocal of this because this line and that line are perpendicular. So you're going to say, and then you give a reason here. You can even say tan radius theorem, ne? To show. Remember, they can ask you, how did you know this is 90? So you can just mention tan radius theorem there. Then now we sorted, we have y equals to 2x plus c. Remember, y equals to mx plus c, but our m is 2. Now we can substitute this point here. So my y value is 1. My x value is what? It's 0 plus c. Therefore, c equals to 1. Therefore, y equals to 2x plus 1 is the equation of the tangent. And yeah, that should be it, ladies and gentlemen. Okay, now we need to calculate the coordinates of u. Okay, the coordinates of u. The coordinates of u, it's easy to find them now. Sorry. The equation of du, which is that one. Okay, so I discussed it earlier on. We said the answer is that, right? Since it's a horizontal line, so it's y equals to 6. Now we need to calculate the coordinates of u. Okay, so u lies on this line, right? And we have the equation of this line. And we have the output. So if we have the output, we can always get the input, like vice versa. If I have the input, I can always get the output. So 4.5, we're going to have y equals to 2x plus 1. My x is still my x, my y is 6. So where I see y, I'm going to put 6. Then my x is still x, then plus 1, right? Obviously, I need to move the 1 first, that side, which is 6 minus 1 equals to 2x. Then I have 5 equals to 2x. Then I'm going to divide both sides by 2 so that the x can remain alone. Therefore, x equals to 5 over 2. Therefore, point U is going to be 5 over 2 coordinate 6. And then you're done with this question. So we're done with that. We're done with that. Okay. So now we need to go to question 4.6. Okay. So 4.6, we are required to prove that. Okay, let me get a different color to solve this question. So we'll use the blue color. Ne? We need to show that Q, U, okay, A, D is a cyclic quadrilateral. Okay, so ladies and gentlemen, remember, cyclic quad, the properties of cyclic quad that we can prove are this. Ne? If I can prove that this angle, this one here, is the same as that one, I have proved that this is a cyclic quad. Why? Because this chord DQ will be subtending that angle and that one, right? But for sure, that way it will, or also if I take this angle and this one, right? Or this one and that one, or that one and that one, right? But that way, in this case, is going to be a tedious thing to do, ne? It's going to be a tedious thing to do. The other idea that I can use is this. This angle here outside, which is the exterior angle, has to be equals to that one, right? If I can prove that that angle there is 90, then I've proved that this is a cyclic quad. Why? Because the exterior angle will be equals to the interior opposite angle. And that way, it's easier to do. Why? Because I have a 90-degree idea. I can use what? I can use perpendicular lines here. If I can show that the gradient of this line and that line multiplies to -1, then I proved that that angle is 90. Ne? Okay, so we need to do M of AD and M of AU. Ne? AU, sharp. Let's do it quickly. So I'm going to start with AU. So I'm going to call this my ones, this one my twos. So I'm not going to write the formula, guys. I'm sure you're used to the formula now. So here, My y2 is 6 minus my y1 is 11 divided by my x2, it's 5 over 2 minus 0. Okay, let's set up this one now. That is my ones. I'm gonna call this one my twos. Yeah. So my y2 is 6 minus y1, which is 11, all over. Let's see now. Let's check. My x2 is negative 10 minus 0. Right. Perfect. And then this will give me how much? Okay, let's check on a calculator quickly. Let's just use calculator to save our time. So I'm going to start with this one. So it's going to be 6 minus 11 over 5 over 2 minus 0, which is, I'm not going to write because minus 0 is like, doesn't make any effect. So I'm getting what here? I'm getting negative 2 for this one. Perfect. Now let's see how much we're going to get for that one. So the top is still the same. I just need to change the bottom. Okay. Just need to change the bottom. So the bottom is negative 10 minus 0, which I'm not going to write. So it's half. So I'm getting a half here. Now I'm going to multiply the two gradients and see if I'm getting negative 1. So MAD multiplied by MAU. The answer is half multiplied by negative 2, which is negative 1. Therefore, AD is perpendicular to AU. Right. Therefore, it means that angle there is 90. Therefore, DAU, or you can say UAD, or you can just say angle A because that is the whole angle. Do you see it? Is equals to 90 degrees. Okay. Therefore, DQE is also 90 degrees, right? This one you can just say proven if you want to write the reason. Therefore, you can now conclude to say QUAD is cyclic quad. And then your reason is going to be, let's see our reason. You can say converse. So converse means reverse. Converse of exterior angle equals to int op angle in, so I'll just go there, in a in a cyclic quad. Then finito. Just like always, ladies and gentlemen, don't forget to share with family and friends. And if you haven't subscribed yet, please click the subscription button for more content like this. I hope this was beneficial, and we will meet again in another session of Maths Fanatics. Danko.